Question 12. Which of these materials is an insulator? Water, lead, sulfuric acid solution, or graphite? Water is, of course, a type of molecule. Lead is a type of metal. Sulfuric acid solution is a dissolved acid. And graphite is a carbon compound. So, because lead is a metal, it's a good conductor. The electrons in a piece of lead are free to move around. If we have a sulfuric acid solution, then we have dissolved positively charged hydrogen ions and dissolved negatively charged sulfate ions. Because both of these ions are free to move around, sulfuric acid solution will conduct electricity. Graphite is made of carbon, which at first might seem suspicious because it's a non-metal. But graphite is one of the few materials that doesn't contain metals, but still conducts electricity in its solid form. Graphite, the carbon compound, is also used to make the lead in lead pencils. The last option then is water. So this must be the correct answer. Pure water does not have any free charges to act as charge carriers, so as an insulator. Technically, it is very weakly conductive. It does have a few hydrogen and hydroxide ions. It's sort of like water being dissolved in water. But out of all these, it's certainly the least conductive, and so it's the most like an insulator. Question 13. Which of these materials is a conductor? Well, easy, right? Pick the metal. There aren't any metals here. We have sodium chloride crystals, iron oxide, which is a metal compound, dissolved sugar, and ionized nitrogen gas. So let's go through our options. Sodium chloride crystals at first looks like an alright choice, but remember that sodium chloride, and any other salt, will only conduct electricity if it's dissolved, or if the ions are free to move. If we have crystals, then the salt is in a solid form, which means that the ions are locked in place. Salts can only conduct electricity if they're in the form of a liquid, whether that's dissolved in water or if the crystals themselves are heated up hot enough to melt. B says iron oxide, which also looks promising because it contains iron, right? Well, I'm afraid that's not good enough for a conductor. Iron oxide is not a metal, it is an ionic substance called rust. The electrons of the iron are tightly bound by the oxides, and that means that they are not free to move through the compound. So iron oxide, though it contains a metal, also contains a non-metal, and this prevents the electrons from moving around freely. Dissolved sugar looks a little promising as well. We know that dissolved salt conducts electricity. But the thing about the dissolved sugar is that it doesn't separate into positive and negative ions, because sugar is of course not the same thing as salt. So even though it's dissolved, it stays neutral, which means that the water doesn't become any more conductive. The last option then is ionized nitrogen gas. But hang on, I thought gas couldn't be a conductor. Well, if we ionize it, we can stop calling it ionized gas and start calling it plasma, if we like. So D is the correct answer. If we have a plasma, in this case nitrogen plasma, then the electrons of the nitrogen molecules are stripped away by the intense heat or the intense electric field. That means that we have positively charged nitrogen ions and negatively charged electrons, both of which are free to move. And this means that the nitrogen plasma can conduct electricity. Question 14. Name an insulator and describe how it can be transformed into a conductor. Now, it might be tempting to write down something like a block of wood, but it's not very easy to make a block of wood conduct electricity. So what we need to do is think of perhaps a conductor to start with that's not metal, and then figure out how to change it into something that is not a conductor. So in the previous question, we looked at a few things that looked kind of like conductors but weren't. If we can find a way to transform those into conductors, then that's our answer here. We might say something like a gas. Now, a gas is an insulator, but if it's ionized by making it very, very hot or putting a very strong electric field across it, it will become a conductor. So there's an example, gas, of an insulator, and an example of how it can be transformed into a conductor by making it very hot. But that's not the only example that you could have used. If we have a crystal of salt in its solid form, then all of the ions are locked in place, and so the crystal is an insulator. But if we dissolve it, or if we heat it up so that it melts, then these ions are free to move around. And this means that dissolved salts, or molten salts, are conductors of electricity. Question 15. Most conductors are made of metal. Give 3 examples of conductors that are not metallic. Now think back. Can you remember any? Well, we have graphite, which is a carbon substance that is able to conduct electricity. We have sodium chloride solution, or indeed any solution of salt dissolved in water, because this will separate into positive and negative ions. If we wanted, we could also dissolve an acid. So we might have nitric acid solution or sulfuric acid solution. One final answer might be something like ionized neon gas, that is, neon plasma. If we heat up a gas so that it's very, very hot or has a very, very high electric field across it, then the electrons of the gas will separate from the atoms. And in fact, the neon, normally made of atoms, will become neon plasma, which is made out of ions and electrons. Plasma tends to glow, and in fact, neon plasma is what's used to make neon signs. Question 16. Can electrical current flow through insulators? Justify your answer. Now, the yes or no to the first part of this question will be only 1 mark out of the 2 or 3 that this question might be worth. So in order to get full marks, we need to justify our answer as well. So what shall we answer, yes or no? Well, let's look at the extreme case. If we pass an extremely high voltage across an insulator, like a block of wood or a tree, then can we cause current to flow? Well, yes, in fact, we can. If lightning strikes a tree, that tree is going to conduct electricity, whether the insulator that it consists of likes it or not. So insulators have a very, very high electrical resistance. That means if we put even a very high voltage across them, there'll be almost no current flowing. But a very large electromotive force, a voltage, can still cause a current to flow across the insulator by forcefully ripping the atoms and their electrons apart. So a very large current, such as the current carried by a bolt of lightning, will be able to carry through the insulator such as the tree, even though it has an extremely high resistance. So there's the justification for our answer. So that's the end of the questions. In this section, we've looked at various conducting and insulating materials, even some conducting materials that are not metallic.